In the last section, we added in this function literal right here. We did that so that we can make sure that we only pause before follow-up checklink function calls. So if we had added the time.sleep statement directly into checklink, that would have ensured that we had a pause during the initial fetch as well, which is definitely not what we really wanted. So I'm going to make sure, by the way, that I clean up the time.sleep statement that I added temporarily to the checklink function right here. So that's going to go away. Okay, now at the very end of the last section, we noticed that there was a little warning message here around the checklink function call. So the green squiggly means that this is a warning as opposed to an error. You can notice that the warning says variable L captured by function literal. And so we're going to talk about exactly what that means in just a second. But because this is a warning right here, it means we can still compile and execute our program. So I think we should compile and execute the program and just see what happens. And then we'll come back and figure out what's going on with this warning. So I'm going to flip back over to my terminal and I'm going to run go run main go. Now you'll notice that the first 5 fetches appear almost instantly. And then we get this little pause, and then we start to get another 5 statements printed out here. But you'll notice that each of them appears to be a facebook.com function call, which is very interesting. So it appears that in this follow-up statement, in the follow-up fetches right here, it looks like this L variable, or whatever we are really ranging over, is always receiving only facebook.com as the follow-up variable to fetch. So this is directly because of the warning message that we're seeing right here, range variable L captured by function literal. So let's talk about exactly what's going on here. Okay, so we're going to look at a diagram. So you'll recall when we had been talking about functions and pointers and memory addresses, we saw a couple diagrams that looked vaguely like this. So this is meant to represent the memory on our local machine. We've got some number of addresses and then the actual values that each one holds. Now again, just like the diagrams we were looking at previously, this is not like a super accurate diagram of our RAM. It's just a kind of simplified version of it to help us understand why we're seeing this kind of bug right here where I am only getting follow-up statements for fetching facebook.com. So let's talk about what's going on here. Okay, so right now inside of our main routine, whenever we receive a value from our channel, we are assigning it to this variable L right here, right? So we can imagine that our main routine has a variable L that is pointing at some location inside of memory that holds the address of some website that we need to fetch. Now I put google.com in here, really totally irrelevant. We could say this is facebook.com, whatever. Essentially, we have a memory address, or we have a variable that is pointing at google.com. Now, if we look very carefully at how we have structured this function literal right here, you'll notice that the function literal is referencing L, which is inside the outer scope. So this L variable is defined in the outer scope of the anonymous function, or the function literal. And so when we do this, we are saying, hey, this function literal right here is being executed in a separate Go routine. So that means this child routine right here is also pointing at the exact same memory address. It's looking at that same string. Now here's where things start to get really interesting. As we start to loop through this for_L variable right here, and we start to receive variables, or receive messages through the channel, we are constantly changing the value that is assigned to L. So sometimes this will be google.com, and then at other times after we receive a message, it'll get a new value inserted into variable L, like say facebook.com, or we'll get Stack Overflow. And at every point, both the main routine and the child routine are referencing the same location in memory. And so that's why we're seeing this really goofy error message. It's because the Go routine is still looking at variable L, which might be some other completely different variable, or it might be getting changed over time. So I meant to say completely different value. So when we get down inside of checklink, well, maybe we initially make the GET request with the correct value of link, or with the link that we actually mean to talk about. But then after the request is actually resolved, the link down here, so this link reference right here, might have been changed by the time we get down to these references to link. And so this warning message that we're seeing right here is essentially saying, hey, you are referencing a variable declared in the outer scope of this function literal. And that's a big deal because we are trying to reference a variable that is being maintained or used by another Go routine. So in practice, we never ever attempt to reference the same variable inside of two different routines. Instead, we're going to rely upon the fact that Go is a pass by value language. So whenever the main routine has some data that we want to pass off to the child routine when it is created, and that's essentially what we're doing right here. We want to make use of some data that the main routine has inside the child routine, and the child routine needs it at startup time. And so whenever that happens, we're going to make sure that we provide all of that information as an argument to the function that composes this child routine. Because we pass it in as a function argument instead, that value will be copied in memory. Remember, we had said that whenever we pass a value off, it's always received as a copy in memory. And so what that means is, if we say have google.com right here, and we kick off the new child routine, and we provide google.com as an argument rather than as a reference inside of the outer scope like it is right now, then google.com will be copied down to this other memory address right here. And the child routine will reference this address instead. So now the child routine has a very stable record of what link it is attempting to fetch, but the main routine can continue to change this address as much as it pleases as it starts to receive new values through the channel. So this can then change over to facebook.com or Stack Overflow, whatever it is, but the child routine is still looking at its copy of the original value, which might be, say, google.com. So what this really means in practice, and by the way, sometimes your editor will give you a little hint to remind you not to do this. That's basically what this hint is saying right here. So in order to fix this up right here, we need to provide L, so the link we're trying to fetch, as an argument to this function literal right here. So we're going to pass in L as an argument. Remember, this set of parentheses right here is the set of parentheses that actually executes the function literal, just like we have parentheses after a normal function like this right here. So we are passing in L as an argument to the function, the function literal. I keep wanting to say anonymous function because I write a ton of JavaScript, but it is technically called a function literal in Go. Now we do have to make sure that this function right here is told that it should be expecting to receive a link as an argument. So we do have to receive it as an argument inside of the actual function definition. So right here we'll say L, or it'd be nice to say link string. You'll notice we can call this variable name right here absolutely whatever we want, and it's not going to conflict with the link that's declared in any outer scope here. But I'm choosing to call it link as opposed to L, because if we called it L, that'd just be really confusing, like which L are we referencing here? So I'm just going to kind of arbitrarily call it link instead. And now inside of check link, rather than passing in L, we're going to pass in link, like so. Okay, so when we make that change and save the file, the warning message goes away. So now, when we receive a message through channel C, that new value is assigned to L. We pass L off to the function literal right here. That string is copied in memory, and then the Go routine has access to that copy as opposed to the original value of L. So now L can change as much as it pleases, and we don't have to worry about still having our Go routine referencing that same copy or same address in memory. Okay, so let's now flip over to our terminal. I'm going to end this process by hitting Control C, and then we will start up our program again. And now when we run it, we're going to see those 5 fetches again. We're going to wait 5 seconds or so, and then eventually there's our next 5. And you'll notice that now they correctly are all with different domains. And over time, as these different addresses start to retrieve information at different rates, eventually it'll turn into kind of a constant flow because, eventually the pauses of making the request will kind of even them all out. And even now, as I'm watching this, it looks like they're kind of getting more and more staggered over time, as opposed to always updating at the same time. Okay, so that's pretty much it. Some of the real big high points with channels, with Go routines. Remember, the big takeaway with Go routines that we just learned right here is that we never ever try to access the same variable from a different child routine. Wherever possible, we only share information with a child routine or a new Go routine that we create by passing it in as an argument or communicating with the child routine over channels. We never try to share variables directly between them. Otherwise, we're going to get some really weird behavior like the one that we just saw that's going to inevitably end up with some really confusing stuff. Okay, so that's pretty much it for our initial run through on goroutines and channels. Now, of course, these are both topics that are very confusing, so let's take a pause right now. We're going to continue in just a minute with a little quiz just to hit some of the high points and a quick refresher on what goroutines are and what channels are. So quick break, and we'll get to that quiz in just a second.